Okay. Uh, this is a toughie, but we can do it. I think that I did not give you enough space to solve this problem. I never do, right? I never do. So, imagine this. This is a very weird scenario. What's happening is that imagine that we are in the Parque Lincoln, and so you are here, and you have like a little boat, no? And so this boat, maybe you are not exactly there. Maybe you are here. You're wearing blue jeans. You look super cool with your blue jeans. And you have your little boat. So the thing is that this boat starts moving with a vector of I plus 3j. O sea, this vector is moving with a vector of u, I plus 3j. And then you are like, oh, yup. Then you pick it, and you have your boat here. Then you go and you pick it. I don't know, maybe you are like so happy with your blue jeans that you feel that you can walk over water. I don't know. You go, you pick it, walk back here, and said like, okay, now let's go for another vector. And you go for another vector, W. Okay, so the thing is that you had a boat. You let it go into one direction. You collected it, bring it back to the initial position, and let it go into another direction. And first, you want to find what is the angle in between these two vectors, theta. O sea, the angle theta in between these two vectors. Okay. Your formula booklet. Anastasia told me, thank you, Anastasia. In the formula booklet, you have that the angle in between two vectors is b1 w1 plus b2 w2 plus b3 w3 over the magnitude of b times the magnitude of w. So this is actually o sea, if you observe, this is the dot product of b and w, and this is the magnitudes, no, of b and w, no, of b and the magnitude of w. So if you go into the answers, you can see how to do it like manually. O sea, in this case, remember, o sea, in this case, observe that w1 w3 and b3 are both equal to 0 because the vectors are not in the space, are in a plane. O sea, like, let me just write it down how to do it with the calculator. O sea, with the calculator, you can do, for example, cross product. You can do dot p of the vectors. What are my vectors? 1, 3, and the vector 2, -1. And then you can do the norm of 1, 3 times the norm of 2, -1, and that gives you a number. I don't have the number. So you have that the cosine of theta equals to a certain number, and then to find the angle, you use inverse cosine, no? And that should give you 98.1 degrees, rounded to 3 significant figures. Okay. So then, the problem is telling you that during the first journey, no, the part U, the boat took 6.3 seconds 6.3 seconds to travel around 7.56 meters. And then it is asking you to tell me what is the velocity of the boat. But what is the velocity? What is the velocity vector? The velocity tells you the direction and the magnitude, no? So, like, I know that u being, what is u? U is 1, 3. This is the direction of the boat. And this number, the number 7.56 over 6.3, this is the speed of the boat. So what do I want? This is not the velocity vector. Why not? Because if you actually calculate the magnitude of u, what is the magnitude of u? You can calculate it using the formula or the calculator. O sea, if I use the formula, that is 1 squared plus 3 squared, that is a square root of 10. And I don't know what is the square root of 10. Let me see, I have a calculator here in my pocket. The square root of 10 is 3.16. And that is not the same as this, no? Porque this is 7.56 over 6.3. That is 1.2. So u is not the vector. U is what I want to conclude from this. O sea, because these two numbers are not the same. What I can conclude is that u is not the velocity vector. Okay, it is not the velocity vector, but how do I turn it into the velocity vector? Well, so it's the same as we were discussing before, no? In problem, I don't remember which one. So if you have vector u, and vector u has a length of 3.16, okay, then I can consider the vector 1 over 3.16 times u. This vector is going to be a vector that has the same direction, but it's going to have a length of 1. And then, because I want this, but this again is not my velocity vector, because this will have a length of 1. So by multiplying it by 1 over 3.16, what I am doing is that I am shrinking it into a unit vector. And then I want it to have a length of 1.2. So what do I do to turn it into my velocity vector? Well, I take this guy, and this guy, I multiply it by 1.2. This will be my velocity vector. My velocity vector is taking 1.2 over 3.16 times u. That is why in your answer key, take this number, multiply it by u, and that will be your velocity vector. I am not going to do it because that implies that I use a calculator and I don't have one. Maybe I can do, I don't know, I cannot do it. I cannot do it. That is my velocity vector. This will be my velocity vector, no? I hope that makes sense. What I am, an idea that I want you to have in your mind is that I can ask you for a vector, in the same in problem 5, I think it was. In problem 6, I don't remember. In problem 7, I am asking you for a parallel vector with a specific length. So if I want a vector to have a specific length, I divide by the current length and multiply by the new length. You know something? I'm gonna write that down. This is a great moment for you to take a screenshot, no? So, a vector parallel to u with magnitude of, I don't know, x, that is x over the magnitude of u times u. This is how you get a parallel vector with a particular magnitude, no? That is what we have done in problems 7 and 8. Okay. Now, given that during the second journey, the boat covers a distance of 5.1, find the distance between the endpoint of the journeys, no? So let me just do that diagram here again, larger. This is a trigonometry moment. So you have a triangle, and you know that the angle in here is 98.1. They have told you that in the first trip, it was a displacement of 7.6, and during the second trip, it made a displacement of 5.1. No, and you want to find this distance. So if you have side angle side, you need to use either one of the rules, and I think that this is calling for the cosine rule, no? So v is going to be equal to a 5.1 squared plus 7.56 squared minus 2 times 5.1 times 7.56 times the cosine of 98.1. And because I want the and not the squared, this is the square root. You need to learn how to put this into the calculator, and the answer, rounded to 3 significant figures, should be 9.70. Cool.